The Indian Association of Structural Engineers, also known as IAStructE, was conceptualized and constituted in the year 2002 by a group of senior professional structural engineers from all over the country. IAStructE is registered under the Societies Registration Act 20. One of 1860, IAStructE is a national apex body of structural engineers in India with a mission to promote structural engineering profession and cater to the professional needs of the structural fraternity. In the short span of 2 decades, association has attained an eminent position in the professional field. Its membership is valued very highly in the profession. Since inception, IAStructE has been led by eminent structural engineers like late Shri Mahendra Raj, late Shri Shri Kumar Ghosh, Shri Subhash Chand Mehrotra, Professor Mahesh Tandon, Shri Alok Bhaumik, Shri Manoj Mittal and Professor R. Pradeep Kumar. As its president, IAStructE is a permanent member of Engineering Council of India and interacts with the government on professional and policy matters related to civil and structural engineers. To expand its reach, IAStructE has collaboration with various international professional like-minded associations and institutions. IAStructE's prime objective is supporting and protecting the profession of structural engineering by upholding professional standards and acting as a mouthpiece for structural engineers in India. IAStructE endeavor to ensure that its members develop the necessary skill in structural engineering and work to the highest standards by maintaining a commitment to professional ethics and standards. IAStructE is actively engaged in organizing several continuing professional development (CPD) courses for structural engineers to help them update their knowledge and advance their career paths. It also conducts refresher courses for young and practicing engineers and student-oriented programs, seminars, workshops, conferences, technical lectures and discussions related to the latest technological advancements, and case studies are also organized regularly for members to enable them to continuously update their knowledge and skill set by interacting with the best minds from the industry. IAStructE's activities are widely appreciated and known for quality technical contents. IAStructE is also actively engaged in publishing its quarterly journal Structural Engineering Digest (SED), code commentaries, professional guidelines, and a monthly newsletter. IAStructE's publications are becoming popular with time. IAStructE has representation in various technical committees of BIS and IRC as well. Its members are actively contributing to National Code of Formulations. In the year 2020, IAStructE started National Awards competition to stimulate interest in the structural engineering field and to promote innovative thinking and creativity. The awards are presented to the winners in recognition of their outstanding contribution to structural engineering in the categories which include Outstanding Structure, Outstanding Structural Engineer, Outstanding Woman Structural Engineer, Promising Young Structural Engineer, and Best Master's Thesis in Structural Engineering. IAStructE is currently operating from 4 regional centers, namely Eastern, Western, Northern, and Southern, having its headquarters in Delhi to inculcate the professional culture and provide handholding to the budding engineers. IAStructE has its student chapters in several leading engineering institutions as well. Membership of IAStructE is open to all civil and structural engineers engaged in structural engineering profession. Members are elected based on their qualifications and experience in different grades as per eligibility requirements prescribed in the bylaws. Each application is carefully scrutinized before electing the members. More information about IAStructE is available on its website www.iastructe.co.in.
Hello, Vikas, can I proceed?
Yes, sir, please.
Dear friends, welcome to the webinar. Today's speaker is Engineer Sandeep Gupta. We are grateful to Engineer Sandeep for sparing his valuable time and sharing his experience. Brief CV of Engineer Sandeep Gupta. He graduated from NIT Kurukshetra and thereafter did his master's in structural engineering from NIT Allahabad. He joined in Indian Railway Service of Engineers on the basis of 1989 exams conducted by Union Public Service Commission. He worked on this project in various capacities from Deputy Chief Engineer, and finally at CEO level, heading this prestigious national project. During his association with this project, he visited Italy, Denmark, France, and Switzerland for gaining first-hand knowledge in the state-of-art tunnels and bridge construction technologies. He was deputed to INSCAD Singapore for Advanced Management Development Program and ICLIF Kuala Lumpur for Financial Management. Under his leadership, he was associated with prestigious national project, which was finally completed and on 14th January 2025. And this prestigious project was inaugurated by Honorable Prime Minister in June 2025. He was involved in the construction of Anji Bridge. Is the first cable stayed bridge on Indian Railways for broad gauge railway line crossing at Anji in Riyasi district of Jammu Kashmir. The salient feature of the bridge, this bridge is part of prestigious national project, the Udhampur Srinagar Baramulla Rail Link project, and constructed in the young cold mountains of Himalayas, having extreme, complex, fragile, and daunting geological flows of the mountains, supporting one foundation of main span was stabilized by special hybrid foundation in Katra and due to space constraints. Anji Bridge is located in Katra Riyasi block section, and its statutory CRS inspection was done on 7th January 2025, along with successful special trial on 8th January 2025. CRS authorization for this section was received in January 2005 and was ready for dedication to the nation. This bridge was finally inaugurated by Honorable Prime Minister in June 2025. The Anji Bridge was completed, including track linking of blast track, Anji cable stay bridge, serving as a testament of the engineering prowess of Indian engineers, It stands as a marvel of modern engineering and a landmark structure. The bridge was dedicated to the nation by the Prime Minister on 6 June 2025 at the time of dedication of USBRL. Now, over to Engineer Sandeep to proceed further and share his knowledge and experience to the participants. Dear Sandeep, please proceed.
Thank you very much, Dhawan sir, for giving me this opportunity. I also thank IAStructE for extending this opportunity. I hope my talk, my lecture, my presentation would be useful to all the engineers, all the budding engineers, and I am always open to any questions. So, if with the permission of the chair, I'll like to start my presentation.
Please continue.
I hope the screen is visible and I am audible.
Yes, please.
So I'll just start with a very iconic picture of the iconic bridge, the marvel of India, that is Chenab Bridge. What we'll say, a bridge above the clouds, as you used to say for the Mew Viaduct, that a bridge it is over the clouds. It's a majestic picture. I'll start with this. So before taking up the presentation on Anji Cut Bridge, I'll briefly dwell on the overview of the project. That is Udhampur Srinagar Baramulla Railing Project, which is 272 kilometers long, and it is a national project. It was declared a national project by the Honorable Prime Minister in 2002. Post-independence, this was the most difficult and challenging project for the Indian Railways to construct such a project. It was a dream which was dreamt many times, but now it is a reality. People thought that it will never be done, but Indian railway engineers proved everyone wrong, and now you can check in from Katra to Srinagar by rail in less than 3 hours. And I invite everybody to take a ride from Katra to Srinagar. They can go in the morning, come back in the evening, and by road it takes a lot of hours. That's what. Now, as you see in the alignment, we start from Udhampur, which is having MSL of 660 meters and ending up at Baramulla. For the ease of construction, we had divided the entire project in 4 legs. Since Udhampur and Katra was not having much of a logistic issues, all the sites were approachable by road. Similarly, from Kazigund to Baramulla, it is a very simple, easy area. It is in the valley. The problem was of militancy, of socio-economical issues, which we were able to handle. So, as you see, from Kazigund to Baramulla, 118 kilometers, we got completed and commissioned in 2009. Then from Udhampur to Katra, the works continued. In the meantime, we took up the part of the most challenging, using connecting valley with Ramban mainland. That was Banihal Kazigund. At that time, it housed the longest transportation tunnel of India, that we all call commonly as a Pir Panjal tunnel, crossing the Pir Panjal ranges. The length was 11.215 kilometers long. At that time, it was the longest transportation tunnel. This section was completed in 2013. It was thrown open to the nation in June 2013. Then Udhampur and Katra was completed and commissioned in July 2014 by the Honorable Prime Minister, sir. That I think I am happy to tell you, Honorable PM sir's, Modi sir's first inauguration of any infra project was of Udhampur Katra. That is a railways project. That was done in July 2014. So after completing all these stretches, we were left with Katra to Banihal, which length was having about 111 kilometers. This was the most difficult section, which I'll show you in the salient feature in the next slide. The most difficult part was that none of the project sites were approachable by road. We had to construct a long network of roads amounting to about 215 kilometers in the treacherous hilly region. We had to acquire the land, we had to construct the roads to just reach the project sites, that is tunnel portals, bridge sites. This was a project in itself. Then the inherent psychological issue was there regarding a fear psychosis of militancy and the tough terrain in itself. But we did not budge. We kept on working on it. We had a lot of issues, technical issues were there. People raised issues regarding the viability of the alignment. But we did a small course correction in the year 2009 and 10. And we went ahead with our conviction, which Railway Board has agreed. And we had proved everybody wrong. The people who said that this alignment is not workable, not viable, not safe. By completing the project, by concluding, now the trains are running, I think we have vindicated a stand taken by Railway Board. And in this forum, I would like to thank Rakesh Chopra, sir. It was his dream. It was his vision that the project can be completed. And it was done. In addition, Mr. Vicky Gupta, the retired member engineering, I would like to appreciate him. He had the guts to take the board along with him to continue with this alignment. And there were a number of engineers, which if I say no one can complete such a big project, 100 of engineers were involved. People retired, people transferred. But I was a man, I was lucky. I continually worked on the project from 2012 till its commissioning. This part, that is Udhampur-Srinagar project, though I was earlier associated with Jammu to Udhampur. In nutshell, I can say I was involved in the extension of railway network in J&K from Jammu to Baramulla. That is about 324 kilometers. From the very beginning, I was there. About 75 to 80% of my career, I had been in this project. So with this, I'll just go. And if you see this alignment, Katra to Banihal, from Banihal to Sangaldan, we started opening in the year 2024. I became CEO in September 23. And my endeavor was that before I retire, I had to commission the project. So with this aim, the first block section we got cleared from Commissioner Railway Safety, that is Banihal to Khadi in January 24, then Khadi to Sangaldan in February 24, and we got it commissioned by Honorable Prime Minister, sir, in February 24 up to Banihal to Sangaldan, that is 48 kilometers. Thereafter, from Sangaldan to Riyasi, another 46 kilometers covering 4 block sections. We got it completed by June end, got authorization of CRS on 1st of July. However, it could not be dedicated to the nation because of the intervening elections in Jammu and Kashmir. Therefore, the political bosses thought that we should commission the project in the entirety. The problem was that Katra-Riyasi section. Now, it is only a 17-kilometer section. Anji bridge, which I will be discussing in detail, lies in this block section. This bridge was completed in all respects in 2023. So it was not critical. However, there was a tunnel which we initially called tunnel number 1. The revised number is T33. It is at the foothills of Trikuta Hills, just at the foots of Maa Vaishno Devi. We were having a lot of problems. We were supposed to negotiate a 500-meter length of main boundary thrust. The strata in the vicinity of this 500-meter was practically liquid. It was a, you say technical word is viscoelastic plastic medium. It was highly crushed dolomite invested with water. It was just like tunneling through water. So we used a unique technique in instead of NATM, we used I system of tunneling, though it is not a new technique, but we used it in India for the first time in such a large way. And we were able to overcome this difficulty by October 24. Therefore, after completing the track linking, we did load testing of Anji Bridge, and as it is written in January 14, we got it authorized through CRS, and then waited for the formal commissioning, which finally took place on 6th of June this year. Now, this is a just salient feature of this project. I have highlighted Katra-Banihal section because this is the most difficult and treacherous section, and I will be concentrating only on this. This is 111 meters long. It has 49 bridges. The highest bridge is 350 meters, which is the iconic Chenab Bridge. If you just bifurcate 111 kilometers, 97 kilometers is entirely in tunnels, 7 kilometers on bridges, and only 7 kilometers is in open. In these 7 kilometers, we have located our 7 stations. So you can just imagine how difficult it was even to construct the bridges, and all the stations, all the station yards were on the bridges and in tunnels or in both. So the paucity of space, the difficulty is well aware. 87% is in the tunnels. The longest tunnel is 12.77 kilometers long, which is at present India's longest transportation tunnel in operation. In addition to this 97 kilometer tunneling, we had constructed about 67 kilometers of parallel escape tunnels for tunnels having lengths in excess of 3 kilometers for safety and rescue of passengers. So Katra-Banihal section, if you see, the special features, as I've already told, we had to construct about 250 kilometers of approach route, which was a project in itself. The longest transportation tunnel of the country, that is T50, is 12.77 kilometers long, in addition to a parallel escape tunnel of equivalent length. 87% is in tunnels. 67 kilometers escape tunnels have been constructed. All station yards are located in tunnels or on bridges or both. Another special feature of this project, that is, we can say, first time on the Indian Railways. As you see in metro railways, all the yards, all the station yards are on ballastless track, and the turnouts are canted. They are jointless. So in all those 7 stations, we have provided BLT, that is ballastless track. The turnouts are canted. They are jointless. There are no joints. So when you travel at 100 kmph from through a yard, you won't feel as if you have crossed a yard. Like similarly, world's highest railway arch bridge Chenab is there. First cable stayed bridge on Indian railways, Anji Bridge, though not on the world, but in railways, yes, we have done. People were skeptical whether it will be possible or not. We did it. For the first time, we used reinforced earth embankments up to 60 meters high to accommodate the yards. And for the first time, like in metro railways, on the mainline railways, mainline broad gauge, we have used rigid overhead conductor system, that is ROCS, for railway electrification. I'll just dwell for a few seconds on the Katra-Riasi section because this was the most critical section for commissioning of the entire project. We completed the work well within 2004 December. We did the load testing of this Anji Bridge, but because of the time available with the Commission Relay Safety, the inspection was carried out in the first week of January. We did a successful street trial on 8th of January 25, and we got CRS authorization on 14th January 25. However, due to certain reasons, the entire project could not be dedicated to the nation till February 28th, the time I retired, which I'll always grieve on that. Anyway, the project was finally dedicated to the nation by Honorable PM Sir in June, on 6th of June. So I'll just show you a picture when we did a speed trial on this bridge. This is the day. 8th of January 2025 this year. Then after commissioning of the section, we did trials of Vande Bharat trains because initially it was envisaged to start the train services between mainland and Delhi using Vande Bharat, specially designed Vande Bharat trains because of the temperature and long tunnels. So this is one of our small videos of one of the trials. I'm just concentrating on Anji bridge because my lecture is on this bridge only. Then finally, on 6th of June, the project was dedicated to nation by the Honorable PM. I'll just share a small video of this event.
माता वैष्णो देवी के आशीर्वाद से आज वादी कश्मीर भारत के रेल नेटवर्क से जुड़ गई। उधमपुर, श्रीनगर, बारामूला, ये रेल लाइन प्रोजेक्ट ये सिर्फ नाम नहीं है, ये जम्मू कश्मीर के नए सामर्थ्य की पहचान है, भारत के नए सामर्थ्य का जयघोष है। चीना ब्रिज दुनिया का सबसे ऊंचा रेलवे आर्च ब्रिज है। हमारा अंजी ब्रिज भी इंजीनियरिंग का बेहतरीन नमूना है। पूरा करना मुश्किल था, चुनौतीपूर्ण था, लेकिन हमारी सरकार ने चुनौती को ही चुनौती देने का रास्ता चुना है। ये दिखाता है विकसित भारत का सपना जितना बड़ा है उतना ही बुलंद हमारा हौसला है, हमारा सामर्थ्य है।
Now, I'll start with the main topic. Sorry, I took about 20 minutes extra.
Doesn't matter. Please continue.
So, now the evolution of idea of construction of Anji bridge across Anji Cut. Sir, initially the Anji, we had two iconic bridges on Katra-Banihal section. These were two bridges, Anji bridge and Chana bridge. At the time of award of the contract, say in 2003-04, both the bridges were planned to be constructed like arch bridges. Just like Chana bridge, Anji bridge was also planned to be constructed. I'll just show you a GAD which was envisaged at that time. This was a GAD for Anji bridge, which is a small Chana bridge. The only thing is that if you will see at the left-hand side, which is Katra side, we have got about 120 meter length is required, and the space at Katra side was very less. There were issues about stability also. So this work was allotted to Gammon JV in 2004. However, due to alignment issues, there was pendency of works. All the works on Katra-Banihal section were stopped by the railway board, and this work was finally short closed as Gammon JV thought that it won't be viable for them to continue the project since it was not sure when the work will be restarted. From 2010 to 2015, the work remained entirely suspended, first because of alignment issue, then because of various PILs and repeated PILs filed by certain people who wanted to derail the project. Finally, when all these issues were sorted out in May 2016, we appointed Messrs. Italfer from Italy. They are just like rights of Indian Railways. They are considered to Italian Railway as the consultant for designing the bridge across Anji. The whole scheme was reviewed and a fresh view was taken to complete the bridge. And the main objective was to complete the bridge in a fixed time frame and to accommodate the two tunnels. Actually, the distance between the two tunnels, that is tunnel number 2 and 3, were already, the construction started. Only 770 meters was in between. So we have to accommodate those tunnels and construct a bridge at that location. As you see, the bridge is big. As I told you, that between T2 and T3, it is 770 meters, is the clear distance. The site is characterized by deep slope and no horizontal space on the left side. At Katra end, that is on the picture, it is on the right side. Practically, there is no space. And on the left side, yes, there is a space. So about 350-meter space is there. On this side, if you see on the left photograph, you will see some piers are constructed. These piers were constructed by the then Gammon JV when the work was not short closed. And you can see a portal of tunnel number 3 also, which was under construction at the time. You can just see the topography, how difficult it was. Now, this is the other end, this is a Katra end. This had lot of discontinuities, issues of stability were there. These are another photographs. So planning a bridge in such a situation was challenging. As I have already explained, due to space constraint and slope stability issues at one of the ends, that is Katra end, that is when we start from Katra, the first end, it was decided to go for an asymmetrical solution in view of available space and good slave stability at the Riyasi end. We had about 350 meters of stretch which we could have used. So an asymmetrical solution was the viable option. For this asymmetrical solution, two types of bridges could have been constructed. One was the cable stayed bridge and other was spandrel truss bridge. The cable stayed bridge was finally zeroed on and decided we should go for a cable stayed bridge. After we did a SWOT analysis, because they're considering time, cost, and maintenance aspect, I'll just show you small. This is a SWOT analysis. You know, opportunity of asymmetrization, we can go for a cable stayed bridge, we can go for a truss bridge. This is the analysis. Cost of construction for an arch bridge, it was maximum. For a cable stayed bridge and for a spandrel truss, it was comparable. Time of construction was minimum for a cable stayed bridge. We had fixed timelines and we thought, yes, it can be done. Risk in phase construction was also minimum for both cable stayed and spandrel truss. And as far as maintenance goes, cable stayed bridge was considered to be having the least effort. So based on this SWOT analysis, we decided to go for a cable stayed bridge. However, we had certain demerits. Merits, I have already said that on Katra side, only small foundation would be there, a small abutment, where the bridge will be resting. We won't be disturbing that slope. Then all the works will be carried out only on one side, that is the Riyasi side. No heavy equipment was required to build this bridge. For Chana bridge, we had to construct lot of enabling works. Here, only a single tower crane was required to be erected. Then construction phases were clear and well defined. Construction time is comparatively less and a reliable program can be prepared. I am happy to share with you, sir, whatever we had planned. We planned that this cable stayed bridge would be completed in a timeline of 5 years, and we did it. We did it in almost less than 5 years. The only demerit was on Indian Railways, we lacked this experience of a cable stayed bridge, that too in the hilly areas. There are a lot of examples of cable stayed bridge world over. I won't dwell on that just to save time. This was the artistic impression when we started the bridge. As you see on the right side, there is tunnel number T2. Now the new number T34. On the left side, there is tunnel number T3. The new number is T35. The clear distance between T2 and T3 was 770 meters. So the main bridge which we planned for cable stayed to bridge the gorge, the Anji gorge, was 473.25 meter. There was a connection of 38 meters. It was required because otherwise, had we continued the bridge for another 38 meters, the height of pylon would have become uncontrollable. Then we had to make a 120 meter of a viaduct, and then we planned for a central embankment of 94.25 meters. Now you may ask a question, why this ancillary viaduct could not have been extended right up to the cable stayed bridge. The reason is that for the logistic purposes, we wanted to erect our erection workshop there. That is, we wanted to outsource our fabrication, bring the parts, erect in the workshop, and launch it. So that was the logic behind it. Now, this is a general arrangement drawing of the. I am now just talking about the main Anji Khat bridge, which is 473.25 meter long. As you see, the main span, this is a asymmetrical cable stayed bridge. Main span, we say the C span, and the shorter span, the rear span, is the L span. The C span is ranging, it is 290 meters. It is wrongly, in fact, it is 290 meter. And then in the rear, it is 70 plus 85 meter. We have got a small pylon there to support it. And then on the right side, this is what we call a modified abutment, a innovative sort of abutment we call MA2. That is main bridge abutment A2. As you see, we have got, being an asymmetrical bridge, the total number of cables were 24. 24 in the front, in the C section, 24 in the rear section, 24 on the left side, 24 on the right side. So 24 into 4, that is 96 cables. Out of these 24 cables, 12 cables balanced each other. Balanced 12 cables had to be anchored in the MA2 so as to have to balance the bridge. Therefore, we had to construct MA2 with special features, which I'll be discussing in my subsequent slides. On the left-hand side, the MA1 is a small abutment. Only the bridge is resting on it, nothing great, no deep excavation to be done. Slopes need not to be disturbed. That was a very viable solution. And between this abutment and tunnel, the tunnel T2, we hardly had 40 meters of distance. So you can very well imagine when we were constructing, we needed that portion for tunnel construction only, and the entire bridge construction was done from the other areas here. This is a picture of completed Anji bridge. We started with the artistic impression. Now this is the realistic impression. This is as-built bridge. Here you can see on the right-hand side, if you see, tunnel number T2 is there. One small structure, that is A&M structure, is there. A small span of 38 meters is clearly visible. Then 290 meter span, central span, which is over the gorge. This main pylon is 193 meter high. Up to deck level, it is 51 meters. This pylon is inverted Y shape, 71 plus 71, that is the entire height is 193 meters. And in parallel, you can see a tower crane which is attached with this pylon. This tower crane is 205 meter long, high. It is a special tower crane We got it imported from Spain, and this was the heart of the bridge. With the help of this tower frame, we were able to construct the entire cable stayed bridge. Every cable stayed bridge is we have to, when we devise a construction methodology, it is site specific solution. No two solutions can be similar. Here we cannot lift our segment from the gorge. We have to, for launching, we have to erect the segments at one end, take them over the deck and launch it. I'll show you in my subsequent slides. You can very well see a ancillary viaduct at the left hand side and open space for workshop. Now it is a embankment. Just to summarize on the agencies involved, the main client was Northern Railway. The engineer, the Railway Board has given the work of this section to Messrs. Konkan Railway Corporation on nomination basis. They were the engineers. The contractor was Messrs. SCC. We had design consultant, as I already told you, Messrs. Talfron from Italy. Then the slope stabilization was done by ISC Bangalore and IIT Delhi. For proof design of the design, the proof consultant was Messrs. Covey from UK. And as far as slope stability goes, it was IASTructE from US, which did the proof checking through 3DC analysis, for which CTEC, which they are pioneers for it. As I already told you, we had only 5 years to complete the bridge. We did not have the luxury like Chenab Bridge for 20-25 years. So we decided not to go for any fabrication at site. And to ensure proper and good quality, we outsource our fabrication to 4 different agencies. The one of the agencies matters at Moscow and Bhilai. Then Messrs. ArcelorMittal Nippon Steel in Surat. Maximum of fabrication was done at this workshop. In fact, we added at Moscow when we realized that we may be running short of time. So we outsourced some work to at Moscow. Then AML Rajpura did the work for the ancillary viaduct. Messrs. JCL Infra Meerut did the work for the small 38 meters CA2 connection. Then other agencies involved are for wind tunnel testing. We did wind tunnel testing for both the Anji and Chenab bridges because the bridge was spanning deep gorges and winds were critical for these bridges. For this particular bridge, initially the wind tunnel test was done by RWDI Canada when we had planned for a arch bridge. Once we modified the arch bridge to a cable stayed bridge, we got it revalidated through Milan Polytechnic, Italy. Site investigations were carried out by IIT Delhi and IIT Roorkee. For the stay cable installations, we used VSL from Switzerland. The derrick gantry, which was used to load the segments and launch it, Messrs. Bridgecon was used. And for the instrumentation purpose, Messrs. Encardio rights were involved. Now, these are the salient features as you see. From here, it is very, very clear what is the height, what is the span. The main span is 290 meters. The main pylon is 193 meters. It is an inverted Y-shaped pylon. From the gorge bottom to the deck, the height is 196 meters. And from gorge to height top of the pylon, the height is 31 meters. For construction of pylon, we have used Doka jump form shuttering. Since slip forming was not possible, we constructed the pylon in segments of 4 meters, and it was a continuous construction. And the joints were prepared in a very professional way. If you see the photograph, you won't be able to identify the joints. These are the salient features of the bridge. As I have already told you, the main bridge is of 473.25 meter length. 290 meter is the central span. The rear span involves 80 meter plus 75 meters. And then MA2, the main abutment where 12 cables are anchored, it is 28.25 meter long. Then there is central embankment of 94.25 meter, ancillary viaduct of 120 meter, a connection at Katra end of 38 meter, making the entire length of 725.25 meters. The main pylon on which the entire bridge is resting is having a well foundation. Now, constructing a well foundation, a dry well foundation in such a strata was not possible, not easy. we use method of circumferential micropiling, and then we do manual excavation, which I'll be discussing in detail in my subsequent slides. The dia of the well is 20 meters, the depth is 20 meters. Height from well cap right up to Pylon, as I told you, is 192 meter. Height from deck is 142 meter, inverted Y. Height from Anji bridge, again, I am repeating, 331 meters. Material used is in the lower part, is the reinforced concrete. Lower part means till the Y junction. The vertical shaft is a composite steel concrete structure because all the stays are embedded in it. For that, we needed tensile stresses also, tensile forces. So it had to be a composite structure. As you see, the deck width of the main bridge is 15 meters. Now it is very interesting. We had to construct a bridge only for a single line track. The width could have been around 8 meters or 9 meters would have sufficed, but we had to make a 50-meter deck because of stability concerns, because of high winds. So we planned to have a one track broad gauge line and a parallel service road of 3.75 meter width. It for our disaster management. Then the deck width on embankment was again 14.5 meters. For ancillary viaduct, as I told you, it is 9.45 meter, no service road on that. Then deck width connecting the last connection is 13.4 meters. Coming to stay cables, very interesting. As I told you, we had a total of 96 cables. That is set of 24 cables into 4 rear and front cables. These compose each cable composed of 31, 37, and 43 strands. Each strand is of 7 ply. The dia is 15.7 mm. I want to inform the audience that till late, such strands were not being manufactured in India. We got it imported from Slovakia through Becquerel company. Now I understand these are being manufactured by Usha Martin. These STS strands were given corrosion protection for a C5 environment. That's the most corrosive environment, like coastal areas. First, these strands are galvanized, they are greased, waxed, and then PU sheathed. That is 15.7 mm dia becomes 18.7 mm. And every strand is replaceable. So this is a single strand, and 31, 37, 40 strand make up for a cable, depending on the design. So at the end of the rear span, the deck is rigidly connected with two 28.25 meter long MA2 abutment, where 12 plus 12 stay cables of the rear span are anchored, making Anji bridge an asymmetrical bridge. All the bearings are spherical. The design life of the bridge is 120 years. The maximum speed for which it is designed is 100 kmph. The service loads have been designed as per MBG 87 loading of railway loading. Design loading is IAS railway codes. However, the design of structures has been done using BS and Euro codes. The critical wind speed based on our wind tunnel testing is 213 kmph for a 3-second gust. Thus, though, as per the earthquake zoning zones, the Anji Khat location lies in zone 4, but we designed for zone 5. We did site-specific spectral studies through IIT Delhi, and based on the maximum critical earthquake and PGA parameters, we designed the bridge. These are certain quantities which I will not agree, which I will not dwell much on. You can just see how the enormity of the bridge. Only thing is that for the main pylon we use 159 micropiles. Some cable anchors were used for the slope stability, and so forth, so forth. Main interesting part is the stay cable installations. 96 cables were used. The length of each cable varied from 80 meters to 290 meters, depending on the length of the bridge. If we add up the entire strands, the total running length is in the range of 650 kilometer plus. That is distance from Anji to Delhi. The weight was 850 tons. Just imagine weaving 650 kilometers of strands one by one. How much time and effort it must have taken. Then there were special bridge expansion joints because being a very small, big span bridge, special BEJs had to be manufactured. We got it done through Foslo. Then SEJ, that is such expansion joints or rails. We call them as rail expansion joints, special rail expansion joints. These are also special, not used on Indian Railway as yet. Again from Foslo, 2 numbers were used. Then track linking was 780 meters. An aberration is here. The entire section from Katra to Banihal has been designed and constructed on ballastless track. But for this Anji cable stayed bridge, we decided to go for a ballasted track. The reason is that because there is a camber of 40 centimeter at 2/3 of length, and this camber had we provided ballastless track BLT, then it would have cracked. You know, it's like a chain link. On a bridge, when we lay ballastless track, we have to give margin for adjustment of camber when the loaded train comes. So what we do on a bridge, we make ballastless track in a in length of 4.1 meters, giving a gap of 10 centimeter between two slabs, so that as a chain link, it can go up and down without fracking. Had it been in the case of Anji Bridge, what we had envisaged in the beginning, then we had to construct 1 meters slabs, which would not have been practical. So we went for ballastless track in this particular stretch. Now, another unique feature of the bridges are pylon. We have already discussed. The bridge has been designed in active discussion with DRDO for blast loading test. You know, if there is a explosion of 40 kg TNT on the deck, it won't be affected. If there is a blast of 100 kg TNT at 20-meter distance from the abutment or pier location or pylon location, it won't be damaged. The bridge will keep on standing. Then adequate redundancy has been built in the design. Redundancy means, suppose during construction time or during operations, two consecutive cables on either central span or on the rear side gets damaged, we can still run the trains at a reduced speed of 30 km/h. If 3 consecutive cables get damaged, the bridge won't collapse, but the train service has to be stopped. Then as for the central embankment, for the first time on Indian Railways, we had used a cementitious earthwork for stability. Now it was an innovation. Now I hope railways would be wise enough to use it. The bridge has been designed for Zone 4 earthquake forces. However, a site-specific analysis was done by IIT Roorkee, and based on the parameter given by them, we had designed the bridge. The bridge is having a service road of 3.75 meter along the track because we have got escape tunnel in T2. From escape tunnel, you can go along the road, and on the other side, this is only for emergency conditions. Then state-of-the-art instrumentation for structural health monitoring of the bridge has been done. On this project, we have provided state-of-the-art instrumentation system for monitoring structural health of bridges on 4 bridges: Chenab Bridge, Anji Bridge, Bakkal Bridge, and Riyasi Bridge, which is having a separate control station everywhere. For Anji Bridge, we have got a control room right inside the main abutment 2 on the bridge itself. The bridge has been designed for a critical speed of 213 km/h for a 3-second gust. As I have already told you, 8260MT structural steel was used for superstructure styrene boxes. Now coming on the construction methodology and launching sequence. As I have already elaborated that we had a mandate to complete the bridge in the shortest available time, which was decided as 5 years. So we had to plan a scheme very meticulously so that we can do a lot of activities in parallel and the bridge can be completed, including load test, in 5 years, including load test, track linking, everything. So first part was what we started. I am not discussing about the ancillary viaduct or the that part. That was done separately. We can consider it a separate bridge. For the main bridge, construction of main pylon, that is 190 meter high, at Riyasi end was the biggest challenge. So we started working on that. And I can tell you, for construction of the foundation, we used 159 micropiles, and driving those 40-meter deep micropiles was a difficult task, and it took us almost 1 year just to complete the piling work. In the meantime, in parallel, we had to establish a workshop at the central abutment. For that, earthwork had to be done up to a certain level, because we could not have done the earthwork up to rail level, then we could not have launched our segments. So first part of earthen embankment with cemented earthwork, retaining walls were used, constructed by the time MP1 was completed. In order to enhance the work, to speedify the work, we decided to outsource all the fabrication to renowned outsourced fabrication workshops. I have already told you it was given to 4 workshops. Then those fabricated workshops, we planned which length, what size of segment components can be led to site. And the assembly of the segment was done at site. We planned to erect segments of 10-meter length. The width was 15 meter, and that was the scheme. Then for the initial launching, we had to do initial launching of 198 meter, not by this cable stays or direct gantry. We had to launch using push and pull method, because on this pad, we had to transport our segment for segmental launching. Then deck casting of 198 meter, which we had done by push and pull method. Thereafter, we had to erect the direct gantry, and with the help of that direct gantry, the balance to 42 meter was to be launched. And thereafter, deck casting of this 242 meter was to be done in 3 phases as per the designer's scheme. So just to summarize, the main pylon 100 meter had to be constructed at Riyasi end to be completed well before we start our cable launching. Similarly, workshop had to be assembled and the segments to be erected in the workshop the moment we had to start the end launching. 10-meter long span I have already discussed. All the segments which were fabricated in the outsourced workshops were jointed by HSFG bolts, M27 10.9 class HSFG bolts. We had ensured that no welding takes place at site to ensure quality. So incremental launching I already discussed, then launching by direct to 42 meter I already discussed, then casting of the deck. Now going stage by stage, I'll just take you through 5-7 minutes. This was the phase 1. As you see, pylon has been is under construction. By that time, we have reached the deck level. My MA2 has been constructed. My MP2 intermediate support has also been constructed. Then phase 2, my workshop is ready. The earthwork has been done. Steel girders for incremental launching, we have to erect a 32-meter long launching nose. Fabrication has to be completed. We erect the 10-meter segment, connect with launching nose, and then we launch the initial 198 meter using push and pull method. In fact, it is pull and push method. We use 500-ton jacks with wire strands. We pull the strands. There is a spreader beam behind the erected segment, and once we pull the strands, it will push the segment. This is pull and push method of launching. So phase 3, that is completion of this pull and push launching. By this time, my pylon was completed. You know, all the activities had to be dovetail. The time I completed my launching of this pull and push, pylon is ready. You can see there is a cantilever of 48.75 meter beyond the pylon. It cannot have been launched beyond that, otherwise it would have become unstable. Now, next stage is that we have to make up the MA2 abutment and earthwork so that I can now launch my segments over this deck. Therefore, it has to be made up. So that work was done in phase 4. Then phase 5 involved erection of my direct entry, the launching entry, for facilitating launching of my segments. Now there is a catch. What the problem occurred, this is the plan given by the designer, but at site it was not feasible. I would like to emphasize to all the budding engineers, all the seasoned engineers are always aware, every bridge has site specific issues. They cannot go theoretically what designer says sitting in Italy. We are at site, we have to use our head, we have to use site specific solutions, and we have to have an interactive session with designers to convince what can be done, what cannot be done. The problem was that the designer decided that the launching entry has to be erected right at the end of the segment which has been launched. Now, for erecting this gantry, I needed a tower crane. My tower crane had a jib length of 35 meters and a capacity of 25 tons. It could not have been used to erect the gantry. So, as I was chief at that time, I gave a solution to my site team, to SCC people, that why don't we erect this gantry at the pylon location, have rails after erection, because that can be done using the tower crane, and then push it to the end of the already launched segment. Now, Italfer was not agreeing to it because it had to be with some stresses and all. But on my insistence, they did their recheck the design, and finally they had to agree to it, and this way the things were done. Now you see, after the gantry was shifted to the location where it was there, the deck was cast. The deck was cast because now we wanted to move our segment over the deck so that it can be launched by the direct gantry using stay cables. Now, next stage, even before I start launching of my first segment, I had to install 2 sets of cables and stress it, because the gantry itself was of 200-ton weight and the individual segment was of 150 tons. Had we not stressed these 2 cables, then the gantry, this thing would have toppled. Just to give more strength, we had to first, without even launching, we have to install these 2 sets of cables and stress them. Thereafter, we have to launching was possible. In the first stage of launching, 10 segments of 10 meter long, that 100 meters were launched. The segments are 15 meter wide. As you see, when we in my video, I will show you the segments were erected in the workshop. They were lifted by a crane. Then they were placed on a motorized traveler, and traveler used to run from MA2 to the launching location just below the derrick. And then there are cables on both the sides. So for this, we had to turn the 50-meter segment in 90-degree so that the leading length is 15 meter and width is 10 meter, and it was able to clearly pass through the cables. After completing this 10-meter launching, we did the slab casting. Okay. Now, after slab casting, I'll show you in my subsequent slides. After launching of each segment, we used to measure and draw the profile of the deck, the profile of the pylon, and the levels of the top of foundation. Compare it with those given by the designer. Yes, there had to be variation. We used to share with them in Italy, and only after they gave us go ahead, we used to launch the next segment. So you would appreciate, we had planned to launch 3 segments every month. That is 1 segment per day, per 10 days, and we ensured that it was done. We were monitoring it on 24-hour basis. The team of Northern Railway, Konkan Railway, SCC, VSL worked in tandem. It was an amazing show of team workmanship. I would like to acknowledge this fact, sir. So after this, we, based on designer, first stage distressing of all the cables was done to lift the already launched deck to the profile what was envisaged by the designer. Thereafter, we went ahead and launched another 10 segments. Last 3 segments were launched without any stay cables as per the design. Already explained. Then we went ahead for, before uh, laying the deck for the last portion, we had to put some loading on the derrick entry. Because had we not done this, if we did re-stressing of the cables, there were chances of upliftment. So based on that, our profile, we were very lucky, we were very fortunate because of our good workmanship and quality control, close monitoring. The last segment perfectly launched, got rested on the abutment. Thereafter, as per the designer, we did final restressing of the cables. Then the deck was cast. The ballast and the gantry was removed from the other end. Now, you see, we have already done the cabling work completed, deck completed, profile is perfect. But for future analysis, we need to know what is the force in each of the cables. So every time when we work out the actual force in the cable, in the subsequent slide, I'll show how we have done the weaving. We have done it by single strand by strand. We have done the weaving, but at that time, but using a single jack, single strand jack. But for finding the lift off for cable loads, we had to use multi jacks, which was specially brought from Switzerland. With the help of those jacks, we were able to assess what is the forces in the cables. So as per the designer, the cables were restressed and the forces were fixed. Now for posterity, yeah, during maintenance, it won't be possible to work out the forces in the cables using a multiple jacks because the cables would have been cut. So we have done, we have used accelerometer to recheck the forces. Using accelerometer and by calibrating it with the forces, whenever in during a lifetime we want to know the force in the cables, only we have to provide the accelerometer and we can work around the what are the stresses there. In addition, in the instrumentation part, in 16 of the identified cables, represented cables, we have provided load cells for live 24 hours assessment of loads. In phase 15, we finish the work, we lay the track. Again, using accelerometer, we find out the force in the cables, check with the designer's cables, and when it is ensured that no restressing is to be done, then we cut the cables and fill it with grease and provide the caps. This is the complete bridge picture, which has been done. Now I will just, you must have been bored by my lecture. I will show you a small video prepared by when the bridge was not exactly completed. It will show you the push and pull launching method, then the launching method used by Derek. Thereafter, I'll show you another video only for launching. So if you permit me, I'll just show you the video. Sorry, I'll just stop at this location. I'll show you another video of a segment launching, which is more interesting.
Now, please.
This is a segmental launching. The most interesting part of this launching, you may see, this photograph shows a very, very flimsy launching gantry. You know, this gantry had a capacity of 200 tons.
Mhm.
My segment was 150 tons.
Mhm.
The yellow part is the hoist, which lifts the gantry. And then there is a cantilever portion of 10 meters where the gantry is taken and lowered. We had a limitation of the load because designer has told us the gantry cannot be more than 200 ton of weights. And we need a space also. So entire gantry seems to be very, very flimsy, very, it was not giving much confidence to me. We started to launch the first segment in May 2022. Mr. R.K. Gupta of Bridgecon, late R.K. Gupta ji, he was a very good friend of mine. His company designed this derrick gantry. I discussed with Gupta sir because he had worked with me earlier also. Gupta ji, I am not very, very sure. I am not sure whether this is going to work. I am worried my segment may not crash into the gorge. He assured me, Sandeep, nothing will happen. You just go ahead with it. At that time, I was in Delhi. My father was not well, but I was connected on video. And Mr. R.K. Gupta showed me, look, Sandeep, the segment has been launched. Perfectly okay. I was very happy. I came to Jammu back. When I was going by the lift above and coming down, I just saw some signs of distress in one of the welds. These are the things which a good engineer should always be open to. Because if we don't give attention to small details, then catastrophes can happen. When I saw those small cracks, I was worried. I asked my deputy chief here. It was evening at about 4 or 5 o'clock, and you go climb the gantry, see what is happening. That day only, the new chief administrative officer has joined. He had no stakes at that time. I told him, sir, things are not good. I am going to stop the work. Till that time this gantry is retrofitted, erected, tested, only then I'll continue with my launching. Now the time frame was very, very strict. Relay board would not have accepted a stoppage of 1 month. Then my CEO, then CEO told me, you are taking a big risk. I am new. You are the arrowhead. You are going to get the stick. I told him, sir, let him suspend me. Let them suspend me. Let them transfer me. But I will not go ahead with any further launching. Till the time I am sure the derrick is okay. Sir, we took 1 month to retrofit that derrick. The fixed joint had to be changed to hinge joints. Certain external processing was done. Thereafter, we made a checklist that every 2 hours, what levels we have to check. So thereafter, when we started the launching, for 10 days, the initial 3 days were like a patient is in the ICU. For 3 days, none of us slept. Till that time, load sharing happened by fixing of the top cord and splicing done. Then loads are shared. For the first 3 days were hell like hell. And this continued for the next 11 months. That means 1/3 of the month, 10 days we never slept every month. So this was a sort of dedication the entire team had. I am not telling, I am saying about me. Each and every member of the team, say it from Northern Railway, Konkan Railway, HCC, VSL, this was the spirit of the work, and the entire work was done without any issues, very safely and perfectly. Even the Italfer, the designer, which constructed the Po River Bridge in Italy, they said they had never come across such great parameters during launching. Sorry for if I have said more. Now, this is the complete picture. If time had time been there, I could have gone for hours and hours, but I will take some time to dwell on the construction of MP1, that is main pylon, which people will be
Please,
interested.
please.
Now, as you see in this figure, the dia is 20 meters of the proposed well. For facilitating the construction of this dry well, we have to construct, put in place micro piles of 20 centimeter dia. The hole was 24 centimeter, central center of 40 centimeter. The piles were 40 meter long. The depth of the pile initially, as decided by the designer, was 30 meter. They envisaged that the founding level would be about 20 meters. But as an abundant precaution, I was worried we may have to go further deep. I took a call to increase the depth of the piles from 30 to 40 meters, so that if we were required to go deep, then still we will be having this required grip length. So this is the way we did it, as you see. And initial drilling of the micro piles was very difficult. Lot of problems were there. Frequent jamming of the machines was there. It took us about an year. We started micropiling sometimes in October, say April 2018. And the work was completed, the micropiling work in about 2019 May. So more than a year. These are some pictures, how we use the machines to do the micropiling. I'll show you a small video also. Once the piling was completed, then we had a top well cap, which was 1.4 meter wide and 1 meter depth, before starting our excavation. Excavation was done using excavators. We had a high capacity crane to lower our excavators. You see the way we are excavating, you can see the enclosing macro piles. They are not exactly straight. This is the best we could have done. We had a 40 metric ton capacity crane to lower the entire pokelane inside and to take out the muck. Now we have reached the founding levels. Before we decided on the founding levels, our consultant from Italy came, they went down the well, assessed, and then they gave us a green signal to go ahead. Yes, now we can plug it. Then we placed 24 columns of RCC at the periphery before doing the concreting. Now concreting has been done in M35. This is the top of the this thing. Now well cap has been cast. Now after casting a well cap, we have to start the construction of main pylon, for which we needed a tower crane. We made a foundation for tower crane just adjacent to the pylon. The tower crane was from Comanza, Spain. The height of the crane was 205 meter. Our pylon was 193 meter. Good enough. The jib length was 40 meters and the crane capacity was for 25 tons. As you increase the length of the jib, the capacity will come down. So these factors had to be kept in mind while erecting our main pylon. This is a small video how we erected this special tower crane.
Main pylon MP1
This
of
tower
Anji
crane is
Bridge will stand
self-building.
tall to a height of 193 meters from its foundation. For construction of such a high structure, there is a need of assistance of tower crane, which goes along with it and makes this structure possible. Tower crane commands a 21 cm 550 of 25 metric ton capacity is chosen for this role. Tower crane mast section is set into a raft foundation with steel pedestal. Mast section are plumbed to required degree. Concrete support and then crane is ready to be erected after curing of concrete. After that first step is to build initial tower. Tower comprises a series of sections called masts. 4 such masts are connected with the use of separate crane. After masts are set, top climbing unit is added. This component is a special section that is set over top mast and bigger in size, thus allows for insertion of more masts. Without this, tower crane would not be able to grow. Once initial masts and top climbing units are added, it is time to construct slewing assembly, which consists of horizontal jib, counter jib, cabin slewing ring. After slewing assembly is put together, a separate crane is used to lift and attach it to the mast. Now, top climbing unit, initially set around the current top mast, is necessary for the crane to increase its height. When it's time to grow the crane, top mast is disconnected from the slewing assembly. Through use of hydraulic jack, the climbing unit lifts itself and the slewing assembly. At this moment, the climbing unit is set between the slewing assembly and the top mast. The trolley on the crane's horizontal jib then grabs a new mast unit and slides it into the climbing unit. This new top mast is then encased by the climbing unit, just like the initial top mast. Once this new mast is secured to the mast underneath, the climbing unit raises the slewing assembly and repeats the process. Once the project is complete, disassembling a tower crane follows this process in reverse.
So this was just a small
Great.
explanation how we had erected this tower crane. In the similar fashion, we had dismantled it also. Now the bottom of the pylon was that 51 meter height. It had 3 chambers, central and hollow chambers basically. And the entire pylon was constructed using Doka jump form shuttering. So for Doka jump form shuttering, it was erected at site. We used to cast segments of 4 meters, and then after casting, the entire shuttering was jacked up by 4 meters. So jacks were used. Now this is the right side. You can see the Doka jump form shuttering. Outside shutters are lifted by jack, and inside shutters are lifted by the tower crane. I'll just go briefly, and you can see how the construction progressed. You see, in this Doka jump form shuttering, there are 3 platforms. Top is the working platform where we stand and do the concreting work. Then the first platform is there where we adjust our brackets and jacks. Then the second platform is there where we do the finishing work. And the bottom is there where we do our curing work. And let me add here, up to deck level, we used pumped concrete, and beyond deck, we could not have used pumped concrete because height was too high. And in the entire pylon, we have not used water as a curing compound or curing agent. We have used a special curing compound. Now this is the way it progressed. Now we have reached the deck level. Up here, this pylon cap, deck cap had to be cast. This is the time just before, this was around January 20. You see, it has to be, the cap has to be widened to accommodate the legs of the inverted Y. So the pier cap was pre-stressed. They were only in one direction pre-stressing was done, one single end pre-stressing. And one interesting feature is that when we were doing pre-stressing and casting of this pier cap, COVID was at its peak. In spite of COVID, we did not stop the work. We had a lot of fight with the state machinery, but we just went ahead with the work in a missionary zeal. Now these are the cables. Stressing is being done. Now the pier cap is completed. After the pier cap, we have to start for the inverted Y. The angle is 83 degree from vertical, from horizontal, and 70 from vertical. Now separate set of shutters are there. Now one important thing is that for concreting, we could not use pumped concrete because of the height. We have used a pneumatic concrete bucket with the capacity of 3 cubic meter with the help of the tar crane. Now, interesting feature is that whenever the concreting was going on in these segments, Y segments, it generally used to take us about 12 hours. And all the people, all the workers, all the supervisor, all the engineers used to go climb the location of concreting by a tower crane, which had a small cage. But once they were at site, the cage was disengaged and the concrete bucket was attached, which means that for the entire 12 hours of concreting, nobody could have come down. Food was sent above, and for nature calls, I will not discuss further. But this was the type of dedication we did. I myself was there for 3 sets of concreting, continuous for 12 hours. And my deputy chief engineer and excellence were 100% available. That's why we were able to achieve such a good quality. This is the way we are progressing. Now, as you see, when the two legs come very clear, very close, then one of the the shuttering of one of the legs had to be dismantled. That is, one of the legs concreting has to be stopped because the space is becoming very less. Now you see, right hand side the concreting has stopped. Left hand side we are taking over. Once the left hand side is over, then we will take up the right side. Now the two are almost at the equal level. Now there is a cap has to be constructed at this level. Now, because over this vertical shaft would be constructed, which will be composite, all the cables will be encased in the vertical shaft. Therefore, this pier cap was pre-stressed in both the directions. And the grade of concrete was M55, mind it. This is the, you can see the pre-stressing cables. These are on both the sides. Now pre-stressing is done, completed, grouted, capped. Now we have started the construction of the final vertical shaft, which is a composite structure. You see, we have got fabricated steel pylon boxes of dimensions 5 meter by 1.1 meter of different heights. We used to place those boxes at the location, connected with accessory boards. They had shear connectors around them. Then we used to do the reinforcement work. So by doing so, the area became so congested after reinforcement that normal concreting was not possible. So for the entire vertical shaft of 71 meter, we have used self-compacting concrete. Now this is, you can very well see the steel boxes. One innovation we did, what the consultant was not agreeing. You see, the guide pipes had to be welded with the steel box, and there are guide pipes at the deck level. These guide pipes are not at the same line. They are splayed because the width of the deck is 15 meters The width of this thing is less than 15 meters. So a very precise angle has to be set for each and every guide pipe. That exercise we did in the workshop, very perfect engineering, so that the angle is perfect, because such type of engineering cannot be done at the pylon site. So this was one of the changes we did against the design scheme, and it came up very well. You can see we are erecting the boxes on the right hand side, doing the reinforcement work and concreting. You can very well see all the, now in this picture, the pylon is completed. Right side, you can see the ducts. There are 24 guide pipes on the left side, right side, for all the cables on both the sides at a very specified angle, which was just used to be verified using total stations and precise surveying. Now the cap at the pylon could be cast, could be closed only after the completion of all the cable stressing work. That was the last activity. Now at the top, we made a temporary platform placed to hoist for lifting my stay cables. Now this is one of the photographs. You will see by the time my pylon is completed, my end launching using push and pull has been completed. That means I am perfectly as per my schedule. Now the next stage is to erect the gantry. Now that I'll come later on. If you want, I can just show you a small animated video
Please show.
only for the pylon construction. Thanks for your patience.
Sandeep,
Sir,
I have got 2 or 3 questions now. Since time is not there, I'll request Vikas that he should mail you those, and then because he so many questions, now the time for you and for the many people are now leaving the webinar. So I'll request Vikas to send you the questions, and then you can rarely reply them, and then we can circulate that. Will that be okay?
definitely. This is
Now, before we wind up, I have got 1 or 2 things in mind, which I will just. One is safety measures during construction. This is my first thing, because so much work you have done. Second one is the life of structure is, say, 120 years, as you have planned and designed. And how we will ensure monitoring for safety of the entire structure for 120 years. So And then see, it's all exposed structure, whether it is steel or RC. I mean, for steel to prevent corrosion, what are the measures we have taken, and for the durability of concrete, I mean, to ensure its life for 120 years. I mean, what are the quality control and the structural monitoring when we say for the entire 120 years? This is my small thing. Please reply and then we'll wind it up.
So, okay, sir. I will take, I think you have raised 4 or 5 questions. I will start from the
Right.
first is regarding safety.
Right.
Sir, if you have listened to my presentation, the gantry part, the direct part, I was able to catch the crack in the weld. So actually, HCC had a separate safety audit team. VSL, the cable installation team, they had a separate safety audit team. Then Konkan Railway and Northern Railway combinedly also had a team of safety. Every morning there was a tool spot meeting, and helmets, this, that, everything was ensured. And I can tell you, sir, in the entire bridge, no accident took place. There was no
Great.
casualty, no accidents. It was done. We were running against time, but that doesn't mean we did any shortcuts. I told you we stopped the war for entire 1 month. I was at the arrowhead. Bombs were blasting
Yes,
in the
yes,
air.
I heard that.
But
Great.
but I did not watch. So that was part of safety. Now coming to the quality part. Sir, quality part in this project has been very, very good. There are three levels of quality control. First quality control is from the contractor side. Contractor gives his quality assurance plan and an ITP. That is inspection and testing plan. And that is QOP. QOP is a statement of how you are going to achieve the quality. That quality QAP and ITP is got examined and vetted by my consultant and the proof check. Based on that QAP and ITP, HCC does their work. Konkan Railway as an engineer, they do their work. They ensure each and everything. And Northern Railway, as per the MOU decided between Railway Board and Northern Railway, NR was having only some sample test checks. But sir, for this bridge, I introduced a system of quarterly detailed quality audit. That is, the team was involved, the Northern Railway team. Every 3 months, based on the QAP and ITP, they used to do 100% quality audit. The quality audit report was a big volume. But as for me, as a chief engineer, I had asked them to just give me an exception report, a 2-page report. What were the exceptions? Where were the failures? And then, if some points were noted, they were communicated to the Konkan Railway and HCC for compliance. And before the next audit, they were complied. And I ensured that one anomaly did not repeat. And we were very ruthless. This was the three level of quality audit. Now coming to the life of the structure.
Right.
Sir, as I told you, the main component of Anji bridge is the cable stay strands. The cable stay strands have been corrosion provided as per the C5 environment. C5 environment is the most corrosive environment, that is coastal area. We don't even require here. Our environment is C1 or C2 in this area, but we went for that so that there should never be a chance for any corrosion. Then the painting done on the structure is RDSO approved scheme. It has a long life, but not C5 paint, which we did on the other bridges. Concrete, the quality is of the highest order. We did not use water for curing. We use curing compound because as it's such heights, water curing is just not possible. Had we resorted to it, it would not have worked. So this we had done. Now coming to the last question of yours, how we are going to maintain it, how we are going to monitor it, sir.
Right.
Let me tell you, we have provided a very elaborate instrumentation on this bridge and for bridges structural health monitoring. The entire bridge has been instrumented. About 114 instruments have been provided. The
Mhm.
control room is inside MA2, which you can see. It's a big room. And EMC has been given to, it was planned to be given, I'm not sure what they did after my retirement. And cardio rights for the people. They did the instrumentation. The Italford, the agency, the design agency, had given the three limits: awareness limit, attention limit, and danger limits for every parameter. And they have also given at every limit what we have to do. That is, suppose we have provided wind anemometers. If the wind velocity increases to 72 beyond 72 kmph, we have to immediately stop the trains. Similarly, for horizontal and vertical movement of the long span, we have provided GNSS, that is Global Navigation Satellite System. We have provided seismographs to find out if any earthquake occurs and what are the effect of it. Then again, for this bridge, sir, for the slope stability, we have provided 3 total stations, fixed total stations, automatic. Then there are fixed targets, and these totals keep on moving at a fixed interval and give us the profile of the slopes on a continuous basis. And the entire data, though it is coming in MA2, our control station, the data is stored in the cloud also. So all the people who are concerned, they can directly have it on their mobiles, on their apps. This is the way it has to be monitored. I hope
So great,
I've-
Sandeep. Now, because of we'll conclude, and on behalf of Indian Association of Structural Engineers and on my personal behalf, we thank you very much for sparing your valuable time and sharing your experience. It's a great job by you and by your team that you ensure the time and the quality. Both things are really very, very important. So with this note, we conclude the session. And thank you to everybody. And thanks to the speaker, Mr. Sanjeev.
Thank you very much, sir. And I hope you give me more opportunities. We can have more lectures of more time. And
Absolutely.
I can give presentation on the entire project on the other bridges also.
Absolutely.
And, sir, if I'll be more happy if we can have an interaction in a physical forum.
Absolutely. We will have a full day seminar somewhere where we'll listen to you. And then
that is better in interaction.
I agree with you. We'll have the full day session where the geotechnical investigation, planning, and the construction, all those things. We'll listen to you.
Such types of bridges are, it has got lot of details. I can give a presentation for hours and hours. This is only a part of it, and everyone would be interested. I'm more interested in the young budding engineers.
Absolutely.
Sir, for Indian Railways, this cable stayed bridge is the way forward. Chenab Bridge has been constructed, but I don't think it will be constructed. It may not be constructed again.
Yes. This is what Rakesh told me. This is the first longest cable bridge constructed by my friend Sandeep.
So I hope it is not the first, sir. Many more will be constructed, sir.
Many more will come. Yes. Thank you once again.
Thank you,
and
sir.
With that note, we conclude the webinar.
And thank you all the participants. You can just mail me the questions. I'll be happy to give them.